Hi, I'm Rob Milner, a Director of Global Business Development for FLIR. One of the valuable report templates provided in FLIR Thermal Studio is called Default Severity version 1. A report created with the default severity template provides the user with temperature values that are adjusted to take into account electrical load and wind speed, and also to provide a text repair timeline recommendation based on NETA thermography standards for direct measurement of electrical components that are intended to conduct electricity. It is not intended for non-conducting components such as insulators or to estimate temperature rise on indirect targets like transformer bodies. Temperature rise corrected for load and wind conditions provides a normalized understanding of the true risk of failure associated with a deteriorating electrical component. To use this template, select the images you want in the report and create a report using the default severity template. A pop-up will appear where you can add information to the report about the inspection date, thermographer, and other information. The template requires the following inputs to work properly: actual load in amps on the conductor being measured, nominal or maximum load in amps of the same conductor, wind speed factor called FCVA, which the user determines based on the wind speed versus FCVA table on page 2 of this template. Of course, all the standard object parameters such as emissivity must be input correctly. And finally, Box 1 must envelop the hotspot of interest, and Spot 1 must be on a suitable reference target. To input these values, double-click on the thermal image. Move and resize Box 1 over the hotspot. Move Spot 1 to an appropriate reference point. Adjust emissivity and other object parameters as needed. Then select the Text Annotation tab and make appropriate adjustments to the load and wind speed values. Click Save and exit. Now when you scroll down, you will see several outputs. Delta T is the actual temperature difference between your hot target and the reference component. Actual severity is based on the delta T value and will change depending on that value. For delta T below 10 centigrade, a value of normal is displayed. Between 10 and 20, repair as time permits is displayed. Between 20 and 40, repair as soon as possible is displayed. And for delta T above 40 centigrade, a value of repair immediately is displayed. Delta T corrected by load uses the formula created by the Infrared Training Center to provide the expected temperature rise of the hot conductor under nominal or maximal electrical loading. Delta T corrected by load and wind uses the combined load and wind correction formula created by the Infrared Training Center and adjusts the temperature to display what would be expected if the load were to be at a maximum and the wind speed were to be at 0. As I said earlier, temperature rise corrected for load and wind conditions provides a normalized understanding of the true risk of failure associated with a deteriorating electrical component. Finally, as part of the report creation process, a summary table is automatically generated on page 3 of the report, which displays a table summary of the location, equipment, actual delta T observed, actual severity, and on which page of the report has more detailed information. To make modifications to this template in order to customize for your own use, simply follow the instructions provided in Section 7 of the Thermal Studio Manual or review the tutorial videos for FLIR Thermal Studio template customization.